Okay, let's talk about the LC3 Datapath. The datapath consists of all the components there that actually process the information that come from the instruction. So here's the block diagram of the datapath. In here, you can see some of the key components in the LC3, such as the ALU, the control structure, the register file, as well as the memory. Okay, so to better understand how the instruction will be executed in the LC3 datapath, I will take some of the instructions that we learned in ECE190 as examples and walk you through how those things actually is being executed inside the control structure. So to do that, we need two things that we can find out from Appendix C. The first one is the state diagram, which is on page 568, and the other one is on the following page. This is the datapath control signals. So without further ado, let's get started. First, let's try a relatively easy instruction. Let's try the end instruction here. I'm going to use the immediate 5 value coming in here. So let's make an example look like this. Okay, so R1 plus 1, 1, 1, 1, 1, and goes to R0. So to do that, let's refer to the state diagram here. We can see for this particular instruction, the state will start from here, go through all these states, and follow the end coming here. Here and it says to state 18, which is the last one, so it comes back here. So that's the whole cycle. Let's do the first state, which is state 18. In state 18, 3 things happened. First, the PC gets stored into MAR, and also PC is incremented, and there's a interrupt. So if there's an interrupt, then after the state, it will go to state 49. But for now, let's assume that there's no interrupt and it always go down and go to state 33. So let's check state 18 in the datapath. So first of all, the PC gets stored into MAR. The PC is here. MAR is down here. So to do that, the PC needs to go to this route. So gate PC need to be opened, which means that's set to 1. Data will follow this path down and this way and down here. Load MAR need to be 1 so that the data will be loaded in here. The other thing is PC is incremented, so PC will also go this way to here is incremented and come to this mux. The PC mux needs to select this bit, which is 0 or 0, 0. So that data will come through here, back to PC. Load PC need to be 1 so that the PC data will be stored in the PC register. Next state is state 33. You can see that M goes to MDR. What this actually means is that the memory content that is selected by MAR will be loaded into MDR. But keep in mind that there's this R in here. And what that means is that basically this state will not be finished in 1 clock cycle, and R will be 0 before it finished. But when this state is down, R will be 1, so that we can move down to state 35. But before it is finished, R will always be 0. So let's get started on how this works out. So M is here. M need to go to MDR. M will follow this path to this mux. This mux, the MIO enable will need to select to 1 so that the mux will pass through the data to MDR. And load MDR need to also be 1 so that the data can load in here. Next state 35. MDR will be loaded into IR. MDR is here again, IR is here. So the data come through MDR, go through gate MDR. Gate MDR need to be 1 so that data will pass through. Go through this path, come to IR. Load IR need to also to be 1 so that the data will be stored into IR. Next state is this branch state. What actually happened in here is 2 things. The first line is basically the state will check if there's the branch condition, the NZP conditions is fulfilled, and the second one is actually what we care about. This is IR 15 to 12 bit, which is basically the opcode, and in our case we're doing add, so we will branch to this state number 1. State 1 is where the 2 numbers are actually being added together, and also the condition code is being set. So let's go back to the data path. You can see in our case we have one data that comes from the register, the other one is an immediate value that came from the instructions. So one data will come down from the register file, the other one will come from the instruction register, and then it's being signed extended, and finally come to B. And in our case, we're adding the two together, and so we need to select the ALUK, so that represents the adding instruction. So let's go to the data path control signal table, and we can see that for ALUK here, add instruction is 0, 0. So we need to choose, first of all, 0, 0 for ALUK, and also let's start from R1. So we need to choose R1. That's in the this is defined in the instruction on the 6th bit to the 8th bit. So it's this line come down here. So we need to select SR1 mux to be 0, 1, and the data of R1 will come down here as the input A of ALU. The other data here we have the immediate value, so it's here. Data will come to here being signed extended. Come to SR2 mux. SR2 mux need to select 1, which is this one. So the data will be coming down here. The ALU will add to 2 data, and the added data comes through here. We need to open the gate ALU, so gate ALU is 1. The data will go this path back to the register file, and the destination register in our case is R0. This is defined by the 11th to the 9th bit in the instruction, so it's this line. The DR mark needs to select 0, 0 to select this one to let DR to be equal to this. And also we need to open load register to 1 so that this data will be actually loaded. After that, we can see in the state diagram that the next state will go back to state 18, so the add instruction is finished.